Good morning, everyone. Welcome to Flink Forward Asia 2025, Singapore. I'm your AI MC today, here to guide you through an exciting day of groundbreaking innovation, cutting-edge ideas, and collaboration in real-time data streaming, AI, and beyond. As your conference for all things streaming data and Apache Flink, Flink Forward is your chance to explore Flink's evolution, its milestones, and its transformative impact on real-time data processing and AI. Now, before we dive into today's exciting sessions, let's take a moment to show our gratitude to those who helped make this event possible. I would like to extend our heartfelt thanks to the key players who made this event possible. Flink Forward Asia Singapore 2025 is proudly organized by Alibaba Cloud. Their commitment to delivering value beyond computation truly sets the stage for our discussions today. We would also like to acknowledge the original creators of the Flink Forward conference, Viverica. Their vision of a unified streaming data platform empowers organizations to derive insights, make informed decisions, and act on data from any source. Oh, and one more thing. Don't forget to capture your experience at this event. Share your Flink Forward experience with us for a chance to win exclusive gifts. Snap and share your photos on LinkedIn, Instagram, or X, tagging #FlinkForward, #Apache Flink, #Fruce, #Apache Paimon. Visit our Share Your Experience desk on the 3rd floor to collect your reward. Let's make Flink Forward unforgettable, one post and one experience at a time. Now let's kick things off with opening remarks from Junhua Wang, Vice President and Head of Computing Platform at Alibaba Cloud. Please join me in welcoming him on stage.
Good morning, dear Flink community members, dear customers, dear partners, dear guests. Welcome to Flink Forward Asia, Singapore 2025. It's truly a pleasure to be here with every one of you. And I want to begin by thanking you to be here with us in this event. Whether you come from across the globe or from nearby cities, your presence today reflects the growing strength and reach of the Flink community. So last year, we had a Flink Forward Asia in Jakarta. We had an overwhelming response. Now we decided to move to Singapore this year. We got more than double the numbers of registrations. So last year was Flink 10th anniversary. We have announced several big improvements. We announced Flink 2.0 last year, and we announced Uniflow, which is a unified pipeline for streaming processing and batch processing. We also announced several other improvements, like ForceDB, like we open sourced Fruce, the streaming storage for real-time analytics. So it's a lot of improvements. This year, we have many great sessions about these improvements as well. And of course, this year, one topic we couldn't escape, which is about AI. We will talk a lot more about real-time AI and real-time AI agents. This event is organized by Alibaba Cloud, which is one of the top cloud providers in the world. And I'm from Alibaba Cloud. So we want to devote into improvements for Flink technologies. We want to reduce the cost of real-time computation, and we want to unify streaming and batch processing. And of course, we want all this to be open sourced to benefit the entire community, to benefit all of our customers. So, by the way, we also have a sister conference in October, Flink Forward Barcelona. So please keep an eye on that as well. And without further ado, so thank you again for joining us. On behalf of Alibaba Cloud and the program committee, I hope you enjoy the sessions and meet new people, live with the new ideas and inspiration. Thank you.
Thank you, Mr. Wang, for setting the stage so perfectly. The evolution of technology has made one thing clear. The future of enterprises lies in their ability to process and act on data in real time. Around the globe, industries are adopting real-time AI and streaming architectures to stay competitive. To help us understand the broader industry trends and the pivotal role of streaming data in shaping this future, our next speaker, Mike Gualtieri, Vice President and Principal Analyst at Forrester, will walk us through why real-time data streaming is the central nervous system of AI-powered enterprises. His keynote, Real-Time AI Defines Our Future, will dive deep into how data streaming developers hold the key to unlocking the full potential of AI and scaling it into impactful, enterprise-wide solutions. Let's put our hands together to welcome Mike Gualtieri to the stage.
Good morning, everyone. I want to thank Alibaba Cloud for inviting me. And for those of you who aren't familiar with what an industry analyst does, that's me, I'm going to go through that a little bit just so you understand the perspective that I'm coming from. So I'm at Forrester Research, and we have global clients, the largest enterprises in the world. And I cover two main research topics, AI and what we call streaming data platforms, so sometimes known as data streaming platforms. So what I do is I'm constantly talking to our clients. They have questions about real-time processing, about AI platforms, about AI infrastructure, these topics that I cover. So I'm constantly hearing from them what they're interested in and what their maturity level is at. But I'm also talking to the vendors, and I'm also evaluating products in the market. And I've been covering streaming data platforms for 17 years. And you might be thinking, oh, did they even have them 17 years ago? Well, actually, my first coverage of this was something called CEP, or Complex Event Processing. And this was stateful analytics way back when financial services firms were looking for patterns in data, either for market surveillance or for algorithmic trading. And I also cover some of the practices as well. So the people I'm talking to are usually the tech leaders and the business leaders. So what I wanted to do this morning is to give you the business perspective of why the need for streaming data platforms is so great and why it's going to expand and get even bigger. And whenever we do the research, we take what is the backdrop of that, what is really the key challenge. And the key challenge in most things, right, is time, and the time that's necessary to do that. And from a data standpoint, all data originates in real time. And my clients are reminding me of that, and I remind them of that when they don't mention it, because we all think of data as maybe it's living in a data lake, or it's living in a data warehouse, or it's living in a database, but it always originated in an instant somewhere else, right? And the trend that's been happening since Flink was conceived and other streaming projects is that data, that time, people want to take advantage of that time, right? And that's why 17 years ago when I started covering this in CEP, complex event processing, financial services industries were sort of the first to try to take advantage of this. And now almost every industry is trying to take advantage of this. And they're trying to get insights from that. They're trying to get events. And the insights that they glean from that is perishable. So at Forrester, we came up with a way, we called the perishable insights. We came up a way for business people to think about the importance of the timing of that data and the origination of that real-time data. So as you can see on this slide, the data originates. There's some analytics performed on it. Perhaps an inferencing is performed on it. But if it goes under this line, we have outdated insights or we have an outdated answer. So if you're asking an LLM some question about some past or something, just some fact or some piece of knowledge, okay, you'll probably get the answer. But if you're asking some supply chain question that impacts the entire supply chain right now, right, you need that answer because you need to make a decision. So we call this perishable insights. So the time to decide is shrinking. Oh, Mike, that's brilliant. It has been shrinking for years. But then if you start to think about AI agents, which I'm getting to, right, and you start to think of agents and how many decisions they're going to make and how quickly they're capable of making it, well, then this time to decide is shrinking even more and at a different scale. And when I say scale, I'm talking about miniaturization, right? So enterprises have invested in data for years. I mean, it's really the first use case for computers, right? And most of that investment occurred in this middle part, this what we call operational insights and performance insights, right? They wanted operational insights to see how they can improve, but not like right now. They wanted performance insights to see how the strategies were working, and so they invest in analytics and data warehouses. But what we've seen in the last few years is a focus now on investing in the real-time insights. And that's why platforms such as Flink have grown. And you can see some examples here of the actual business use cases and some that are strategic. and the ones that aren't strategic, but the ones that are real time, right? But there's also a feedback loop here. So the point of this is that enterprises have invested in this middle part, the data lakes. And I'm not saying these things aren't relevant, they still are, but where they haven't invested and where there's going to be a huge amount of investment, and I'll get to some projections on what that investment will look like later, is on this real time. And that's why you're all here. And this is what you're all interested in. So, but those insights without action are just insights. So, and this is also something that companies have focused on analytics. But when you start to think about the impact on automated agents, again, the time and the scale of this increases dramatically. So you have all of the same business use cases, but at a different level of scale, a different level of information, the telemetry and the data that you need, and the learning that has to take place in parallel. And that's where the unification of real-time and batch comes in. AI is going to be assigning carriers in real time. AI is going to be deciding how to keep customers, how to prevent those customers from churning. AI is going to decide within a few milliseconds, in some cases, like because you don't have too many milliseconds left over on a credit card transaction, whether something's likely to be fraud. AI is going to be monitoring all of the machines and making decisions right now about when to push the machines or when to pull back and maintain those machines. And AI is going to be making all kinds of financial decisions, navigating regulatory requirements. It's going to be controlling production, agricultural production. I mean, it largely is, but not at the level of agents. So my assertion to you is that when we start thinking about agents, it's not just more AI, but it's a fundamentally different AI that's going to need a real-time platform. Otherwise, it's not going to succeed at scale. So things like offering discounts that are hyper-personalized, different scale with different agents, different level of hyper-personalization. And if you take IoT use cases, routing traffic, for example, different scale, different latency necessary. So AI is going to be controlling all of this, but there's different types of AI. And the AI I've talked to you about is agentic AI. And agentic AI is not just about a person. There's two types of agentic AI. There's the AI about a person sort of prompting and getting tasks done. That's great, and that's huge, and that will be very big. But then there's also the automated, the event-driven AI, where an insurance claim comes in, and an agent picks it up, and then it's going to have state. It's going to have to maintain state as it deals with other agents and other tools and agents outside of the organization to process that claim. So we believe there's going to be millions of these AI agents automating processes in enterprises and assisting billions of people. It's already happening. But what enterprises are not prepared for is using these agents within their legacy architectures. Because if you take any large bank, that bank grew through acquisitions. Maybe it made 20 acquisitions. And it has a very complicated enterprise architecture with all of these applications and all of that real-time data that originates in real time. So there's going to need to be some sort of real-time layer for these agents to operate. Is Salesforce Agentforce that layer? No. I mean, it is maybe within their domain. But within all of these enterprise systems, and especially the ones that differentiate, they're going to have to build bespoke applications and a bespoke enterprise agentic architecture. And that's going to lead all of these companies to be incredibly efficient, incredibly flexible. You're going to go from having 200 claims processors down to 10. And AI is software, and we've already used software to automate, and agents are the next step. And then if we even go beyond that, And think of artificial general intelligence, right? The 4 characteristics of AGI, artificial, is that it's going to self-learn, right? Whenever we get a new model, they trained it on this big data set. And yes, there are some continuous learning models. Flink actually can do some continuous learning of predictive models, right? But it's going to learn on its own. It's going to seek out knowledge. It's going to be able to collaborate with other AGIs and people, just like Agentic is going to be able to do, right? But this is going to do it more autonomously. And it's going to be able to act in both the physical and digital worlds, but it's also, maybe very uniquely, characteristically, it's going to be able to build its own tools. So when I think of that real-time layer, and I think of building those tools, what platform is it going to use to build its real-time nervous system? And I was thinking, would AI actually use Flink to build the real-time nervous system that it needs to be smart, right? Because it's not good enough to have a brain. You have to have everything else, all of the sensories. So these AI agents, let's go from AGI back to the agents. So these AI agents cannot operate. We're not going to have millions of agents automating the world at light speed unless it has that pulse of the enterprise. So it needs connectivity to legacy. It needs connectivity externally. It needs an ability to process that information. The AI essentially has to be able to think in real time, and to think in real time, it has to have access to that real-time data. So I don't design Flink. Some of you design Flink. Many of you use Flink and make suggestions. And you probably think about it. You think, oh, OK, well, we'd like this, we'd like that, we'd like this. And it's probably like for your own use. But what if you thought about, what if AI needed this platform? How should we design this for AI, an agentic AI? So that could be a very interesting question. So I asked that question based upon the research that we've been doing with all of these enterprises. I didn't ask it of AI. This is based upon our research with the enterprises. The list is a little bit shorter than I would like, given the time frame we have here. But these are the 7 things to think about, which you already have thought about, the Flink community has thought about, the Flink community has used for years, but now we really have to think about them in light of AI. And the first one is data connectivity and abstraction, because that agentic layer and those agents, they're going to need an abstraction layer. They're going to need an event-driven architect, or they're going to at least need to be able to process events, right? They have to have some way of knowing what's happening in the world. They have to have some way of knowing that they need to reschedule a carrier, or that a claim came in and they have to process that claim. So this goes way beyond just connectivity, but to an abstraction layer that identifies events and even the business objects themselves. So it's going to need to have that level of abstraction if you're ever going to build at scale a series of thousands of enterprise agents. Oh yeah, sure, you can build a few just by bringing in some data here and there, but then enterprise projects are going to stall because that's not a scalable architecture. You're going to have these business object models. The second thing those agents are going to need is it is going to need to be real time, because that's when events happen. That's when customers ask for things. That's when employees initiate things. That's when machines initiate things. That's when agents initiate things for other agents. So it has to be real time, but it has to be real time at scale, which includes concurrency, and in some cases, ultra low latency. And of course, it has to do it cost effectively as well. Right? Because when you start adding LLMs and different mixes of LLMs, and you start adding state those costs can increase. So you need AI, you need infrastructure that supports that, but you also need the software platform like Flink that can accommodate that. The other thing AI is going to have to do is, yes, it needs the real-time raw data, but sometimes the real-time raw data doesn't tell you the entire story. It doesn't show you a pattern. It doesn't show you that when one financial instrument, when the price goes down and another one goes up, that there's an opportunity within some time frame, some few second time frame. So it has to have some sort of stateful analytics and processing, which Flink has. But if I think about AGI and its need to build tools or even agents, those agents are also probably going to have to specify what analytics it needs to get the job done, right? If you think about feature engineering and more statistical AI, a similar thing would happen in agents. So you need an incredibly stateful platform that can also find those patterns in real time that the agents are going to need to make decisions or move to the next step of the process. Another thing that Flink had built in, this notion of stateful analytics. And because you're going to have all of these agents, you need massive scalability of those agents, but cost effectively. So auto-scaling, all kinds of fancy automated features for doing that scaling, which is one of the things that's an evaluation point when I evaluate these platforms. It gets complicated because now you have agents, now you have state, and you have LLMs. So now you have all of these different processes that all have to scale separately, or at least they have to scale separately if it's going to be cost effective. And any of you who actually work on this stuff probably appreciate how difficult it is to do that. And it's also going to need to be fault tolerant, because unlike other data platforms, a warehouse, or just a data lake that's not serving applications, this is operational. This is the company running. So it has to have that the type of reliability that operational applications will have, not the type of reality that people come to expect with data and analytics applications. And I love to call this fault tolerance because it's not uptime. It's not 5 nines or 6 nines or 7 nines or however many nines is required, but rather it's when something does fail. And it's not just at the infrastructure level, it's at the software layer. So can you support, do you have a requirement for 0 data loss? Well, yeah, you do. If you're maintaining state for an agent, right, you would have to maintain that 0 data loss. So again, this is another requirement of agentic AI that it's going to need. And then it's also going to need to have all of the governance, security, and compliance features that enterprises have, yes, because they're mandated to have it by regulatory authorities, but processes that they want themselves because they need to be able to manage their process. They need some level of reliability. But it's much more complicated with AI because the deployment mode of agents is not going to just be, okay, here's the next version of the agent, we deploy it. Because any of you who now operate with machine learning models to make predictions, I bet that's not how you do it. I bet you A/B test models. You probably have, you might have, multiple models concurrently running in production. And that's a risk management strategy, right? So now imagine if you have multiple versions of agents running in production simultaneously. I assert that companies will have to for many processes because they won't be able to tolerate the risk and they won't be able to have the level of testing that they need to be 100% confident that they can deploy that next version of the agent. But the agent isn't just this transformation of some input data to a prediction, like a regular old machine learning model. It has much broader implications because it's going to be taking actions. It's going to be collaborating with other agents. So that governance, security, and compliance piece for agents, much more complicated. But it's going to need that. And of course, it's going to need also the ability to adapt. It's going to have to be open to other types of software, especially other open source projects. One of the things that I love that's finally happening, I mean, it's been happening, is all of the open source models, right? Because when OpenAI came out with ChatGPT, OpenAI was positioning itself as the only solution. That's probably not good for enterprises. And it's clearly not true anymore. But there's a very vibrant, as you know, open source community in models, the frameworks. And the next stage is platforms like Flink to be able to support agents, not just inferencing, but agents as well, and to be open and extensible to other open source projects. So what I've seen in the last year is I've seen open source. Okay, so the way the analyst business works is that we have all of these clients and they ask questions. And when you start to get a wave of questions, then you say, I'm getting a wave of questions. I better write some research about this. So 6 months ago, we started getting a wave of questions about open source AI. And so I published one document on it a month ago. I have another document coming out on open source AI in about a month because there's a wave of interest in this. So enterprises have realized, they already knew, that they have an extraordinarily complex environment and that, yeah, they just can't, in all circumstances, buy something off the shelf to do this. So they realize they're going to have to build and support an agentic architecture that's event-driven, that handles real-time data, that unifies real-time and batch, that does many of the things that Flink already does and some of the things that it's about to do. So that has brought on a wave of interest from these enterprises in open source, and that's going to bring another wave of interest in platforms such as Flink, even more so than it already is. So I think these 7 requirements match perfectly to the origins of Flink, like by design, even before we had agentic AI, but also what agentic AI actually needs in a central nervous system, because that brain of the agent is going to be only, well, it's still, okay, isn't it still true? It's always true that garbage in, garbage out is, you know, what developers have been saying for, I don't know, since there were developers, I guess. So Flink meets those central requirements for AI data processing engine, right? It's both real time, but it can also do the batch that's necessary for prepping for learning. I actually think that there's some sessions this afternoon about continuous learning with Flink and large batch processes, but that also process real time. But it's not enough for the architecture, and that's where the open source community sort of steps in, or has steps in, or always steps in. It's just part of how open source works, with additional adjacent products. And I just listed, you know, probably some of the most important ones, or some of the ones that are most relevant to Flink here: Paimon, Kafka, Iceberg. There's others. I saw we had Fruce up there, and there'll be more projects to this. So the good news is that enterprises are thinking about open source and AI, and they're thinking about this new architectural layer, this real-time, event-driven, agentic architectural layer that they're going to need to roll out. And this is as big as when they thought of service-oriented architectures, well, even before that, web architectures, service-oriented architectures, microservices architectures. So this is the next wave of that to empower and enable these agents. So at Forrester, we call these streaming data platforms, also known as data streaming platforms. And our formal definition of this is, I guess I can read it. Streaming data platforms, enterprise software, it ingests from multiple disparate live streaming sources. And it messages that data. So we expanded this to include like connectivity and messaging because you have to get data in and out. Real-time insights, which must be stateful to detect patterns, right? Otherwise, it's just a piece of data that you're evaluating against some condition. Yes, that's real time, but it's not sophisticated real time. And then also to run arbitrary real-time workflows in the background as well that are needed for real-time as well, or for downstream repositories or applications, right? Those might be connections to something like Paimon or other things even. So when we look at this market, we estimate in 2025 that it's about a 35 billion market. Now you see the technologies on the top. That's kind of important because it's not just one thing. It's a few categories. I did a very formal forecast of this several years ago, and it's very difficult to do because there's pieces of this market. Some vendors have pieces, some have all. The hyperscalers, the cloud vendors, Alibaba has all of these components, right? But sometimes it's hard to slice them together. But our best estimate is that for these categories, it's about 35 billion with a 27% growth rate. But we revised this because we think agentic AI will actually amplify the need for this, right? And that's why I was telling you, I think this is a wave just like web architectures, just like SOA, just like microservices. Perhaps just like big data, but no, it's not like big data. You know why? Because this isn't really an analytics platform. The need here is for a platform that is operational, serving agentic AI. So we think this, I think we estimated it would be about 11% more than an original estimate, and that would bring that significantly higher. I think it could be a lot higher, but I don't think it will, because the AI platforms, which I also cover, right, they have a very simplified view of what it means to connect to data, and they have very loud voices in the market, because when people want to buy AI, they go, oh, here's an AI platform company. And what is the AI platforms company? Oh, yes, we connect to all of these data sources. Oh, yes, we can use data there, we can use data here. So they give the buyer a naive view of the reality of what's actually necessary because they don't have it per se. So that tends to slow things down a bit in terms of enterprises thinking about this and adopting it. The good news is that within an enterprise, the buying center for things like anything related with data was in a data organization and often even in a data science organization. But that's now shifted to enterprise architects, chief technology officers, office of the CIO, and they're much more application focused. So there might be a little bit of a lag to make this growth rate even higher, but nevertheless, we think it'll be significant as more companies think about open source, and think about enabling an agentic architecture. So what I'm reminding enterprises, because remember, I cover AI platforms, so they're asking me about AI platforms. I remind them that they can do a pilot or a little project, but they're not going to scale this out unless they have this real-time central nervous system, that all data originates in real time. Don't think it doesn't, because it does. And the need for it is amplified by agentic, because AI has to think in real time. So enterprises have to invest in a streaming data platform that has all of these capabilities, because they have to build a bespoke architecture to work on their bespoke legacy architecture if they're going to become agent-enabled. And the people who are building that and the people who are closest to being able to satisfy that enterprise need, the people using Flink, the people creating Flink, the contributors, and the companies that are creating Flink. Because that AI, that brain, cannot work without a central nervous system, and you're the ones building it. Thank you.
Thank you, Mike, for that incredibly thought-provoking session. As we shift gears, it's time to take a closer look at Apache Flink and its transformative role in real-time computing. Over the next sessions, we'll explore how Flink continues to empower industries and enable cutting-edge real-time AI capability, a journey into technology you won't want to miss. Our next speaker, Feng Wang, head of Open Data Platform at Alibaba Cloud and Apache Flink committer, will walk us through how businesses are adopting Apache Flink. He'll also share insights into the synergy between AI models and real-time processing, showcasing how Flink empowers enterprises to build cutting-edge, real-time AI agents and applications. Please join me in welcoming Feng Wang, head of Open Data Platform at Alibaba Cloud.
Good morning, everyone. I'm Feng Wang from Alibaba. Now I'm leading the open data platform. Sorry. Okay, it works. Okay. Yeah, I'm leading the open data platform at Alibaba Cloud. So today my topic is about the evolution of Apache Flink from real-time data analytics to real-time AI. Okay, I think everyone knows that last year, 2024, is the 10th anniversary of Apache Flink. So firstly, let's recap the journey of Apache Flink in the past years. So Apache Flink originated in 2009. Yeah. So its origin name is Stratosphere, from TU Berlin University, TU Berlin, Technical University of Berlin in Germany. Yeah, so Stratosphere is a research project. Then 5 years later, the core team founded a company named Data Artisan, and then contributed this project to Apache Software Foundation, then renamed it to Flink. Yeah, but another 5 years later, Alibaba acquired Data Artisan, then renamed it to Vererica, yeah, the creator of the Flink Forward. Yeah. Then Alibaba began to put tremendous resources into this open source project and the community, and drive it into the de facto standard of streaming compute for real-time data analytics in the next years. So even in recent years, the innovation have never stopped in this community. Yeah. So recently we can see a lot of new projects, the new technologies, some innovations in Flink community, such as Flink CDC, which is a real-time data integration tools, and Apache Paimon, yeah, which is a real-time data lake format. So Apache Paimon is originated from Apache Flink community and has been spun off from Apache Flink to be an independent project in Apache Software Foundation. Yeah. So at the beginning of this year, Flink 2.0 was formally released, which is a new start point for Flink community in the next 10 years. Yeah. Okay, from the technical perspective, yeah, I think Flink sits in the very central position of the current of the modern data architecture or data ecosystem. Flink could drive the real-time data streaming from the operational data system to the analytical systems. So Flink could capture the various real-time events from the databases, the messaging queues, then perform the streaming processing on them, then finally sync the result to the data lake, data warehouse. Yeah. After about 1 decade evolution, the whole architecture of Apache Flink has been completely cloud native. Yeah. So it is very easy for the developers to deploy Flink jobs on the cloud environment. Yeah. So actually, most of the cloud vendors have already provided the managing service for Apache Flink to the enterprise customers. Of course, including Alibaba Cloud. Yeah. Okay, let's have a look at another popular data technology, lakehouse, yeah, or data lake. I think now data lake or lakehouse has already been considered as a new generation of the data architecture or data platform. Yeah. So we can see that more and more customers, global customers, began to move their data analytics from data warehouse to data lake to lake house. Yeah. So Databricks, Snowflake, this giant data companies, all of them are promoting their lake house product, lake house solution. Yeah. However, we can see that most of the workloads or the data applications running on lake house still run on offline mode or batch mode, as it's not real time. But from the business requirement side, I think most companies, enterprises, customers also hope to make the real-time data analysis, real-time data processing on lakehouse architecture. Yeah. So how to achieve this target? So I think it's a good idea to bring Apache Flink, this streaming computing technology, into lakehouse architecture to combine the two cutting-edge technologies together to make an end-to-end real-time solution. Yeah. But now, currently, the mainstream data lake format is Iceberg. Yeah. So Iceberg is very popular, it's very powerful, but unfortunately, it's not designed for real time because Iceberg is a batch-oriented design. So in order to solve this problem, since 2022, in Flink community, we incubated a new project. Now its name is Apache Paimon. So its original name is Flink Table Store. So it is a purely streaming-oriented design. It is born for real-time data update on lakehouse architecture. So by leveraging the two streaming technology, Apache Flink and Apache Paimon, yeah, we can come up with a new kind of lakehouse architecture, a real-time lakehouse architecture. So we call it streaming lakehouse because it's built on top of the streaming technology. Yeah. So on streaming lakehouse architecture, we can also provide the end-to-end minutes latency real-time data pipeline. Yeah. So okay, let's think about a question about Apache Flink. Why it could be grow to the community grow so fast, adopt so widely, and become the de facto standard of streaming computing engine globally. Yeah. So from my understanding, it's not only because of its excellent technical design and continuous innovation in the community, but also that it really unlock the value of the real-time data. It really help the enterprise customer to improve their business efficiency, to make their business decision systems real-time. Yeah. So for example, I think in various of the industries, in most companies, the management team, the marketing team could make their business decision real-time by the real-time BI reporting, BI dashboard, which is continuously updated by Apache Flink. Yeah, for the e-commerce companies, they can build their real-time recommendation systems on top of Apache Flink to push the suitable products to their customers to get more attention, to get more transaction, get more click rate. Yeah. For the financial systems, they can use Apache Flink to detect the fraud, yeah, in real time. Yeah. It tells you there are so many different use cases. Now I want to take Alibaba as an example to demonstrate how Alibaba built its real-time data platform, its streaming data platform on top of Apache Flink ecosystem, and make its the group all kinds of business decision systems real-time. Yeah. So actually, Alibaba is not only the biggest contributor for Apache Flink community, yeah, but also it is one of the biggest user for Apache Flink. Yeah. Since 2016, we began to build the Alibaba unified streaming data platform, the real-time data platform on top of Apache Flink. Yeah, we choose Apache Flink as our streaming engine, real-time computing engine. Yeah. So far, I think most of all of the businesses or data applications in Alibaba Group has already been upgraded from the offline data to real-time data analytics. Yeah. So including the global e-commerce businesses, so Tmall, Taobao, AliExpress, and Lazada, and as well as the global logistic businesses, Hainiao, and the online travels, etc. Yeah, all of the business. Yeah. So especially on the I think on the Double 11, you know, this is Alibaba Global Online Shopping Festival. So our streaming data platform, which is running on millions of CPU cores, could handle billions of records per second at the peak time. Yeah. So in order to serve or support such huge workloads, yeah, in real time, our Alibaba's streaming computing team, our technical team has already developed an enhanced version of Apache Flink. We call it a Flash engine. Yeah, which is 100% capable with Apache Flink, but much faster. This Flash engine was built on top of Apache Flink. Yeah, so the API layer and the distributed runtime framework keep the same with Apache Flink. But the core parts, yeah, including the operators, the built-in functions, and the state backend have been rewritten in C++ with vectorization model. So it is much faster than the Java version, Java runtime open source Apache Flink. Yeah. So in order to let other enterprises, especially for the enterprises on outside Alibaba Group, also could benefit from this innovation, this cutting edge streaming technology, we put the whole data platform, the streaming data platform from Alibaba Group to Alibaba Cloud, yeah, provisioning the management service for Apache Flink. Yeah. This product, we call it a real-time compute for Apache Flink. We can also call it RTC in short. Yeah. So it is a one-stop real-time data platform, including the Web SQL IDE, the meta service online debug, yeah, and also it can provide the operational and the management tools for Apache Flink jobs on the cloud, yeah, as well as the core Flash engine. Yeah. So far, it has served more than 1,000 customers globally across more than 10 countries and regions. Furthermore, there are about more than 10,000 real-time applications, Flink jobs on top of it, run on it, driving the real-time business decisions for numerous of the industries customers on Alibaba Cloud. Okay, so I think from the above topics, we can realize that through about one decade evolution, Apache Flink has become the de facto standard of stream compute for real-time data analytics globally, and has been widely adopted in the world and easy to use it on cloud. And there's a lot of commercial Flink offers or Flink services on cloud. Yeah. But what is the future of Apache Flink? Yeah. Could it just be used for real-time data analytics? I think definitely not. So in my opinion, in the current AI area, Apache Flink could also empower the AI system, AI applications, real-time. Yeah. Okay, I think it is everyone knows that in the current AI world, the computing power, the model algorithm, and the data are the top 3 factors for the development, for the evolution of AI technology. Yeah, especially for data, our today's topic. Yeah, it is so scaling law is well known to all of us that the model, the AI model will be more powerful with more parameters. So currently we can see all of the AI models have been becoming more and more larger. The model be larger with more and more data as input for training. Yeah, but on the flip side, the public data, public knowledge on the internet are limited. So rather than the data scaling, I think the data quality, the data freshness will play more important roles for AI technology in the future. Yeah. So just now, Mike gave us a very excellent presentation about the value of the data. Yes, is the more fresh value, more value of the data. Yeah, because of the time. So I think it's definitely right, especially in the AI world now. So imagine that what will happen if the AI system, the AI agent, lack of the real-time data, the fresh data. Yeah. For example, for the custom service chatbots, if they don't have the latest information about the customers, about the orders, about the background of their question, how can they answer, give the customer the right answer? Yeah. If for the recommendation system, if they cannot get the latest behavior, the action of or interest of the customers, they cannot push the right things to the customers. Yes. So there's a lot of kinds of these use cases. So from that, we can easily find out that real time is a native characteristic of AI system. Yeah. So in the future, all of the AI application need to be real time, must be real time. Yeah, must provide the real time experience to our customers. Okay, so next let me to illustrate to how Apache Flink could make the current generative AI system real time. So it is a very typical use cases. Yeah, we can take this example is about Ireland customer service chatbot. Yeah, it's just an example. Yeah, so imagine that someone flew from China to Singapore for this conference. Yeah. Then after his arrival in the airport, he cannot find his luggage. Then he can ask the airline customer service chatbot that, where is my luggage? I cannot find it. So if the AI chatbot have not enough information or latest information about this customer and his tickets, the information about this luggage, this airline, he cannot answer the question, yeah, to the customer. But if we have we have built a powerful streaming data platform. Yeah, behind this AI system, then I think this streaming data platform collects the real-time data from different places and feed it into the AI system to make the AI chatbot updated all the time, and it could give correct answer to the customers. Yeah, so, okay, so next, so I think from this example, we can understand how Flink could make the generative AI system real time, yeah, to help the AI system provide the better experience, yeah, give the correct answer to the customer. Now, let's switch to another trending topic in current AI world. Yeah, it is AI agent, yeah, agentic AI. So recently, various of AI agents have been spring up like mushrooms in the AI world. Yeah, even if there are so many kinds of different AI agents, but fundamentally, I want to categorize them into two different types. Yeah, the first one, I call it the conversational AI agents. Yeah, which is triggered by the users or the human users. Yeah, the human users could interact with it proactively. Yeah, ask some questions and get some answers. Yeah, from this AI-powered application or agents. Yeah. Such as the AI coding tools and the chat BI and the deep research. I think all of us very familiar with these kinds of agents. Yeah. But there's also another kind of AI agent I want to introduce today. We can call it event-driven AI agents, yeah, which is different from the conversational AI agents. It's not triggered by human beings. It's triggered by the systems. Yeah, maybe by some cars, by your mobile phone, by the machines, by some PCs, by some servers. Yeah, yeah, and this kind of agent could driven by the real-time events. Yeah, imitated from the systems, and deliver the comprehensive, the intelligent insights, and take some actions in time. Yeah, so it is work. His working model is not proactive, it's proactively. I think it's reactively. Yeah, such as such as a fraud detection agent, the sentiment analytics agent, the AI ops agent could be considered as the event-driven AI agents. Yeah. Okay, now let's use a concrete use case to illustrate how event-driven AI agent could bring the customers the intelligent insights and some suggestions. Yeah. So I think live streaming selling, everyone are familiar with it. It is a new kind of selling way. Yeah. So in the e-commerce platform, in the e-commerce industries, it has becoming more and more popular. More and more customers want to buy online, buy the products, purchase the product through this way. Yeah. So in the live stream, the audience will send different kinds of messages on the screen, yeah, including maybe some questions, maybe some comments, yeah, and the screen will refresh very quickly, yeah, quite quickly. So I think it's not easy, or it's hard, maybe not, it's impossible for the live host to catch up all of the messages, yeah, in time, or read over them. So let alone get inspired by the information, feedback from the online audience. Yeah. But if we could build a sentiment analytics agent for this system, yeah, then I think the live host could get a real-time comprehensive dashboard, real-time dashboard. So on this dashboard, the live host could not see the traditional statistic report, such as the distribution of the customers, audience, by location, by age, but also he can get a real-time comprehensive report, sentiment analysis report, yeah, such as how many people like his style, dislike his style, or what topics the audience are talking about, and even give him some or give her some suggestions. So by leveraging this new technology, the live host could change his policies dynamically in real time, online, to get more attention from the audience, to get more deals, get more transactions. Okay, I think from the above use cases, everyone can get more information about the event-driven AI agents and what kinds of things, what kinds of values it could bring for us. So next question is how to build it. How to build an event-driven AI agent. So apart from the dependency of the core AI models, the MCP protocol, some general tools, it also needs a very powerful distributed runtime framework. So firstly, it needs a powerful capability for the continuous processing of the large-scale events. Need to collect the events, process it. Secondly, it also needs a powerful state management or AI memory for it, across multi-different events. So last, it also needs a reliability, the fault tolerance, because it is an online distributed system. So as a successful event-driven data processor, Apache Flink, I think it's the best choice to be the real-time runtime framework for the event-driven AI agent. Okay, so in order to build in order to simplify the development of the event-driven AI agent on top of Apache Flink, recently some developers from Alibaba, Confluent, Verica, and LinkedIn has co-initiated a project, open source project named Flink Agents, in Flink open source community, which is aimed to establish a runtime agentic AI framework on top of Apache Flink, especially for the event-driven AI agent. So this framework provides both Java and Python APIs for different personas, and also support the static workflow and the React patterns to build an AI agent. So by leveraging the rich connectors and the powerful Flink CDC streaming processing capabilities, it is easy for the developer to use a Flink agent to collect and handle the real-time events and deliver real-time insights, suggestions to the customers. But keep in mind that Flink is a stateful streaming computing engine. Stateful means there's a built-in, powerful built-in state backend, state management system in Flink internally, which could be used as the AI memory across the multiple events. Okay, so in the last part of my today's my talk, I also want to share something how to integrate the current powerful AI capabilities, the generative AI power into Apache Flink, to make Flink could also do the real-time semantic analytics for customers. So once again, let's begin with a use case, a concrete use case. On the e-commerce platform, I think everyone knows that every product needed to undergo the strict moderation before it is being listed. Because the non-compliant product cannot be sold on the platform. So the traditional solution is to write a Flink SQL to join the product publishing stream and the compliance roles table. To use a stream join. Then use a keyword match function to check if the product title contains some prohibited keywords. I think this is a traditional solution. Essentially, it is a role-based solution. But in current AI area, I think more and more people they prefer to use the intelligent intelligent solution, yeah, the semantic-based solution. So if we can integrate the generative AI capability, the large language model into Apache Flink, then it will be quite convenient for the Flink users to do the real-time semantic analytics. Yeah. So fortunately, in Flink 2.0, there is a new feature named AI function, yeah, in Flink SQL, yeah, which could help the Flink users to call the AI language model services and the vector search in Flink SQL statement, yeah, alongside with the traditional SQL data processing, yeah. So now let's elaborate how to use the new Flink AI feature in traditional Flink SQL. Yeah. So firstly, we could create or define an AI model by Flink SQL with some options. Some options such as the model name, the endpoint, API keys, system prompts. Yeah. The model which are compatible with Open AI protocol will be supported. Yeah. So then the developer could call the AI model services for real-time streaming inference in the Flink SQL, in traditional Flink SQL. Yeah. Even for the RAG solution, it is also convenient for the developers to do the embeddings, to do the vector search in SQL statement in real-time mode. Yeah. So I think I think apparently the new Flink AI SQL, yeah, could combine the traditional relational algebra and the generative AI capability together at the same time. Yeah. Then help the customers, help the developers to do the real-time semantic analytics for both structured data and unstructured data. Yeah. So now let's go back to the previous examples. Yeah. We can create, so let's see how to use a new Flink AI solution to solve this same problem in another way. Yeah. So firstly, let's create a model. Create a compliance model. Yeah. Then in the Flink SQL, we can use the AI function ML predict to call this compliance model for semantic analytics on the title of the product to check if it is compliant. Yeah. So obviously, this AI-powered semantic-based solution will bring us better result, better experience than the traditional raw-based one. Yeah. Even the product without the prohibited keywords on its title, they could also be detected by the AI technology. Yeah. Okay, that's all for my today's talk. So in summary, currently the Apache Flink not only lives on the real-time data analytics, but also thrives on the real-time infrastructures for the current AI system, AI application. So nowadays, most of the AI models can just be trained offline, updated, upgraded in days, in weeks, even months, yeah, very slowly. But I believe that in the future, all of the AI models, or most of the AI models, powerful AI models, could be trained online, for online mode, and could be updated in real-time mode. Yes, AI system could continuously learning as our human beings. Yeah, so at that time, I think Apache Flink as the real-time computing engine will be able to play more significant roles for the AI models, AI system, AI application in the AI world. Thank you.
Thank you, Fang, for giving us a crystal clear vision of Flink's role in the real-time AI evolution. Now, let's move from theory to practice. Our next session comes from the amazing team at GoTo. Akash Goel, Mayank Rai, and Raju GT will share how they built a reliable, self-serve, and scalable real-time data platform using Apache Flink, Kafka, and Kubernetes. This talk will take us through their journey transitioning from Flink's session mode to the Flink Kubernetes operator and practical lessons on multi-tenant architecture, state management, deployment patterns. Please first welcome Akash Goel, Head of Data Engineering from GoTo, to the stage.
Good morning, everyone. We are thrilled to be here at the Flink Forward Asia Summit organized by Alibaba Cloud. In today's session, we are going to talk about how we have powered our real-time streaming data platform using Flink. So let me introduce myself and my team. I am Akash Goel, Head of Data Engineering at GoTo. Along with me, we have Mayank Rai and Raju, who will join me in explaining our journey, the streaming journey, across GoTo ecosystem. But before we talk about more around our Flink journey, let me introduce you a bit about GoTo. GoTo is the largest digital ecosystem in Indonesia. Its mission is to offer technology solutions and improve the lives of millions of people in Indonesia. We have partnered with 20 million merchants, 3 million drivers, and we offer a variety of services, wide range of services in mobility, delivery, and fintech through on-demand platform and our fintech platform. Now, our today's session consists of 4 parts. First of all, we are going to talk about why Flink was not enough for us. And then we will see how we solved our challenges around working with Flink alone and how we improvised our Flink ecosystem with some of the enhancements that we did around our streaming platform. So let's try to understand why Flink alone was not enough for us. So Flink is a very powerful tool, but when we tried to use it for our use cases, we found that there were a few challenges. Number one, scattered data ecosystem. By this I mean is that we didn't have a unified central streaming platform for our users. Teams had to stitch or use multiple tools in order to achieve or get real-time business insights. So we had to create a unified data platform for them. Second, it was too complex for non-engineers. Setting up a production-grade job was too complex for them. And users just want to write SQL. They don't want to get into the complexity of scaling, deployment, and checkpointing. So what they need is simply, can they write SQLs and get insights? It was leading to misaligned focus because they have clear business goals. And their business goals are more about getting data insights, not about managing the technical complexity. And we have multiple Kafka clusters, and users were getting equipped with what data do they use, how do they use, right? So we had to eliminate that complexity, that they don't have to worry how that data is coming. They should just use that data in the form they want to use. And I will take inspiration from Fang's slide, who just presented a few minutes back. There was a slide which was talking about chaotic data sources and how it was difficult to get real-time business insights. It's really true, because we are facing that problem that data sources are evolving. We have too many data sources, and it is getting complex to get those insights. Now, what is our vision then? So our vision is we should reduce the dependency on data platform teams. We should make our ecosystem, our streaming data platform, more configurable, more self-serve in nature. And that is what we did by building a config-driven, SQL-friendly tool for our users. But that alone was not enough. You still need to reduce time to market. You don't want that building a Flink job is taking more than one day. You have to move fast in this competitive world. So with that, we enabled seamless deployment for our users, which abstracted all the complexity around scaling, checkpointing, and deployments. Third, we had to make it more customizable. Why? Because we are not only catering to non-engineers, we are also creating this tool for some of the power users like product engineers. Now, if you are catering to two different types of audience, one who doesn't care about config, they just want to write SQLs. And second, product engineers who are tech savvy and they want more flexibility in providing configs. So we had to make sure like our ecosystem serves all types of audience. And that's where we made it more customizable by providing all types of configs around Flink. And fourth, we had to make sure we take this contribution from the open source community. So the tool that we are going to talk about in the upcoming slides is open source, and we are contributing to the open source ecosystem, and at the same time, many other users are also contributing to it. Now with that, I will invite Raju to talk about more how we implemented it and what is this tool Dagger that helps GoTo evolve in real-time ecosystem. Thank you.
Thank you, Akash. Hello, everyone. Good morning. I'm Raju from GoTo Data Engineering team. Akash just mentioned the challenges and the motivation to build a Dagger tool at GoTo. Now I would like to introduce what is Dagger. Dagger is an open source tool built on top of Apache and Apache Flink SQL or table APIs to solve the real-world, real-time data streaming problems at GoTo. It's a lightweight cloud-agnostic tool, which we are currently running on 3 cloud service providers, including Alibaba Cloud. At a high level, it is a templatized Flink program where all the technical interfaces from the Flink are translated to the features, usable features for our users to solve their problems, equipping with all the necessary capabilities. We can think of it as like, 5 stages where you have the Dagger consumes from the data source, deserializes it, and applies the pre-processes such as like you can add a transformer like deduplicate the records or invalidate the records which are not in the aligned format, and apply the Flink SQL query. Then we have the post processor to enrich the processed output either by using external sources like you can call HTTP services or database, and or you can also transform using internal transformers like SQL within that. And post that, we are going to serialize the data and put it back to the sink, whichever is configured. This is a high-level setup we use for Dagger to function. The Dagger and the orchestrator, which is also open sourced, supports 2 kind of formats. One is Parquet dataset source, and the other one is the Kafka streams. As you can see, there are numerous Kafka streams based on the nature of the data, like throughput or the transactional types. And this was the complexity we wanted to solve at GoTo for our users to not to spend more time on like where to find their data. And we have a stencil which is a protobuf descriptor service which has rich APIs. It helps for all the GoTo products to have a strict data type across the pipeline, and it also solves the data evaluation problems as well. And moving to that, over there you can see we use object storage services will explain more about like why we are using 3 different object storage services over there, which is used for checkpointing, save points, and Kubernetes HA. And then we have the sinks. So once the Dagger processes the output, it either puts it to InfluxDB, it depends on the customer who's using it, for the visualization, or it puts it back to the Kafka stream. We have another tool called Firehose, which reads the data from the DAG stream and puts it to the like sink, like for example HTTP, gRPC, or like we have mentioned all those things in the slide, including recently we added the max compute and OSS from the Alibaba Cloud. Next, I would like to invite my colleague Mayank.
Yeah, thanks, Raju. And hi, I'm Mayank. Good morning, everyone. Thanks for joining. So basically, just to reiterate why we built Dagger. Dagger, we built just to ease the overall streaming in GoTo level. And that was not possible without adopting the schema-first policy across the organization. So basically, schema-first gives the advantage of fixing the contracts. And so to do that, we build a stencil, and that helps us to maintain the schema across the organization. And also, like when we, all the teams, whoever producing a data to Kafka, they have to first declare the schema, and also they have to tag topics with the proto so that it's easy for users to discover it and read and deserialize the data. So basically, the Dagger uses stencil CLI in between and try to serialize and deserialize the data for that. And so now that gives us one benefit is we can build the post processors, which allows us to interact with the outside of services like it could be gRPC as HTTP, and enrich that events. And along with that, Dagger plus Firehose, which is again the open source tool from our data platform. So it's we can build a seamless overall ETL jobs in our GoTo organization. So the key capabilities for our Dagger is it should be scalable. So we deploy all our Flink jobs in Kubernetes operator. We will talk about that in further slides. And so that gives us one benefit is it's scalable horizontally and vertically. In terms of flexibility, so basically one more motivation for building this was to make it flexible for the non-technical folks, right? So they try to write their own code, and they have a custom business use cases which they wanted to extend it. So we don't want to build some system which has the boundaries. We wanted to build a system which can be extendable. And with that, we have allowed users through our DIY portal, the users to write their own Python UDFs and also transformers. And they would be able to do the streaming processing with the Dagger along with this. In terms of extendability, we have separated out the state and the processing. So for the larger window aggregations, we use different state. I mean, basically, we offload that to either HBase or Bigtable, or for that matter, any other stuff. And that empower us to basically have to build basically Flink jobs with the more than 60 days of the window aggregations. So some of the DSLs I'll talk about, which is custom to our Dagger. So one of them is Dart. So sometimes what happened is these few we are talking about, we have a lot more for that. But these are the few important ones which is used frequently. So Dart is, you can refer as a Dagger referral table service. We called it Dart. So sometimes what happened is this mostly used by the non-technical folks like the BI or any campaign managers. So sometimes you get the streams of events, but the event doesn't have all the data, right? So for that, you might need certain reference where you can just enrich it. Those are the static data, might refresh in the day or in an hour. So basically, we have developed two things. One is the Dart get and Dart contains. So Dart get, basically, you can prepare a file. You can create a static data in the key value format, put it into any of the OSs. And just in the SQL, if you look at, just you can refer Dart get, you can give a path which you want to read and what key you want to extract, and then how fast you want to refresh this data. And this will automatically get refreshed when the job is running. And this is useful feature. And then we have a Dart contain, which just gets a list of elements, and then it gives you the binary results, either true or false. This is useful for the non-BI, for the campaign managers where they wanted to target a list of, let's say, merchants. And this is very useful for those folks. And then it comes to Longbow. Longbow is one of our very frequently used feature in Dagger. So it's allow us to aggregate the data over larger window in real time. So this is the same thing, like it's just separate out the state and the processing. So let's say consider a case like you want, sometime what you need to do is you have to know the historical data for the given context, right, when the event is coming. And for that, let's consider we have a login event. Now to build the, let's say, a risk prevention system, you need to know how that device or user is using, right? What is their login pattern? So these things is being done using Longbow. So basically, Longbow has two parts. One is the writer and then the reader. So and it works on the you can provide a DSLs in the SQL itself, and Dagger itself will take care of separating this and then enriching with the context itself. So if you look first part, if you look at this is the Dagger reader, you just provide the Longbow write key. You can assign any key from the data, and then we use this Longbow write key along with the timestamp. We just reverse the timestamp to make this latest data come first. And this will get stored into, let's say, Bigtable or HBase. And then it also writes the event to Kafka so that can be one trigger for the Longbow reader. And Longbow reader basically just reads that, and then based on the configure interval, what you want, how fast you want to go for that context. And it gets the data from Bigtable and then assign it, enrich that event, and that will be, then you can use it for the further processing. So also Dagger comes with the observability. Basically, whenever the user, so it's like we wanted to build a system which is like user can deploy the production-ready jobs within 5 minutes. So through our DIY portal, whenever users creates the Dagger or Flink jobs, it comes with this pre-built comprehensive matrix. So we track like consumer lag, arcade-related metrics like pod, CPU, memory, and then drop events, including a checkpointing states. And also like we have whatever the things we have extended in Dagger, like post-processor, pre-processor metrics, similar to 4xx, 5xx latency, or DB-related databases, interactions-related metrics, is being tracked and will be visible on our DIY portal monitoring tabs. And all these dashboards are already open sourced. And we have, so one of the recent, just to give a context, like we have added a similar, one of the watermarking metrics in our dashboard, like it tells you how far and how past your overall checkpoint watermarking isn't progressing. Yeah, with that, I would like to invite Raju for the deployment.
Yeah, at GoTo, we have tons of services generating billions of events, more than 2 TB of data per day being generated. And most of this data are being processed by the daggers for one or the other use cases from the teams. Earlier, we had around 50 plus Flink session clusters and close to 1K jobs, dagger jobs, which are mostly grouped based on the teams. We had a dedicated Flink session cluster for each teams, and there were common Flink section clusters where if the team had very few daggers, they could use it. So the challenges we faced with this setup was like managing the Flink cluster was getting difficult for the engineering team. I mean, most of the time we're going there. When a new team needs to be onboarded, we had to set up a new Flink session cluster. Or if you want to add a new job, or if you want to scale up an existing job, you had to keep track of all the task slots, which would end up taking more time. There were also like, initially we would ask teams to like how much resource this dagger would take up. But whatever the initial estimate was there, it was like over the period of time, when the product grows, also the resources starts consuming will be more. And the dagger ends up getting more resources than it was initially quoted. And another problem, which also is a very common problem, is that if there is any faulty jobs in the cluster, if it ends up, like JM to restart, job manager to restart, then all the jobs were going down. So this was the, one of the main problem which was affecting the uptime of all the daggers. And at last, the cost attribution. So we are platform team, so we had to attribute the cost for each resources who are using this dagger. With session cluster, it was actually challenging for us to attribute the cost to them. So what we did is we moved to the Flink Kubernetes operator. With this, each job is a Flink deployment, which is a Kubernetes custom deployment, right? So with this, we were able to scale up the dagger both vertically and horizontally, and no more manual management of Flink clusters or in the Zookeeper. And any fault jobs would have impact only on that job. So isolation was done, and uptime of all the other daggers were kept high. And also the cost attribution becomes simpler because Flink deployment is close to Kubernetes deployment as well. So the cost is more on like how many pods are being used. Yeah, and you can see on the right side of the thing, we have 2 ways to deploy our daggers. One is via console. For the heavy users, they can use our DEX CLI, which is also open sourced. Our orchestrator can figure it out, like based on the configurations where it needs to be deployed. All it needs is like the same binary with the different configurations, like which checkpointing directory which it has to use, or the Kafka source or the Kafka sink, and based on that, we're going to deploy in the particular cloud project. Recently, we are supporting Ali deployment as well. I'd like to invite Mayank.
Yeah, so coming back to the feature engineering part of Dagger, how basically in GoTo, Dagger is utilized for feature engineering. So just to give a glimpse, right? So in like Dagger is utilized for understanding and identifying the data. Daggers comes with influx sync, and also it has it comes with, it's Grafana and visualization tools inbuilt. So whenever user try to deploy influx things, you have also the visualization ready. So it's very handy for DS folks to just visualize and get the domain context. And also for the data processing, cleaning and pre-processing, Dagger has a lot of transformer, and also it's extendable. Users are allowed to write their own transformer and UDFs. So they are able to basically handle the missing data or filter anomaly. We have a lot of UDFs in Daggers which can track the anomalies over window, and then it can flag that out, and users will be able to use it as a preprocessor. And also a deduplication can be done using Dagger. For feature construction, we have, you can transform it, you can basically get the temporal features out of any fields. And also you can use geopartial features. We have S2ID, a lot of inbuilt UDFs which can be, which comes handy in terms of the features construction and encoding of that. So I'll just talk about key use cases which we are, which is being handled through a series of Dagger. So basically just to give you an idea about how we chain the Dagger and other tools which we call it firehouses. So basically we have the enrich Dagger and transform Dagger, which just transform and enrich and writes data to Kafka, and then we have a feature Dagger which generates a feature or aggregates it, and then it writes to the in-house feature store. We have developed our own in-house, and also the feast, it can utilize that. And then, or else it can call the actor. So basically, why we directly call the actor, in the sense, let's say, Dagger is also utilized for inference as well. Because through post-processor, we have the capability to interact with any of the gRPC or any service which can be either HTTP or gRPC. So some of the key use cases is like the SLA prediction. So we have two SLA predictions. One is for the food and one for the ride. So when a user basically book the ride, we try to identify the right actual SLA for what would be the time for driver to reach or for the food to be delivered to your home. So in this, we use series of Daggers to predict certain features. I'll not go in detail of that. But yeah, this Dagger is more capable of doing it, and we have hundreds of Dagger running just for these SLAs. Then also dynamic pricing. We basically use Daggers to understand in real time the demand and supply for either for food or for the rides, and then adjust prices based on that. For one of the use cases of fraud detection was the ATO, where the account takeover. We also use their Daggers to actually tag the devices and then try to understand how device is being used against user, and what is the user behavior for using a device, how frequently he's changing a device, or how frequently the user is being changed in the device. So these things is being handled through our Daggers and the other ecosystem, and it's like within 5 minutes, users are able to deploy the Daggers and monitor it. Now, one of the use cases, since we are in Singapore, we wanted to just highlight it, the ERP. So basically, whenever user book a ride here, and the Dagger helps us to basically, try to identify, through Dagger, we try to identify the events from the for the driver location, and try to identify a driver who has the booking. And whenever he passes any of the ERP, we try to basically call the pricing services which can adjust overall at the ERP for that booking. So this is just one of the feature one of the use case we wanted to highlight here. And with that, I would like to conclude our presentation. Thank you.
Thank you to the GoTo team for that dynamic, practical session. Now, let's talk about innovation in unified lake storage with Apache Paimon. Our next speaker, Tin-Song Lee, head of Alibaba Open Source Data Lake Platform Team, PMC chair of Apache Paimon, will demonstrate how Paimon drives minute-level, real-time updates to data lakes, enhances usability with iceberg compatibility, and paves the way for multimodal AI workflows through its latest developments. Let's give a warm welcome to Jing-Sung Lee from Alibaba Cloud.
Hello? Oh, it works. Hello, everyone. My name is Jing-Sung Lee. Today, I want to share something about payment, something about iceberg compatibility, something about multimodal storage. So the first thing I want to share is the timeline of industry development and also the history of birth of the payment. So you can see the timeline. So first thing in 2008, Apache Hive born. So Hive, what is Hive? Hive is Hive Metastore and Hive Cycle and Hive Table. So Hive is built on the Hadoop ecosystem. So built on the HDFS for data lake. And then the column storage born. So the famous column storage is file format, is ORC, ORC, and Parquet. So column storage, so it is the evolution of file format. So column storage has very efficient compressing and scanning because actually in analysis area, there are many scan. You just want to scan a few columns of one table. Imagine a table has 100 columns. You just need 5 columns. So using ORC or using Parquet has very fast scanning. And then the table format, just like Hoodie, Iceberg, and Data Lake born. So the table format, the data lake format is the upgrade table format of Hive. So the lake format provides high performance format for huge analytic tables and more features just like incremental updates. So the table format actually controls the files instead of just like Hive table. Hive table just controls the director of the files, but the table format, lake format controls the files, the manifesto, the statistics of files. So for the lake format can do more than Hive tables, just like ACID, just like delete, just like update, just like merge into. However, the previous the table format, lake format solves batch processing problems. Actually, this is a conference about Flink. So for the streaming processing, we need a lake format, very easy, very good integration with Apache Flink to do streaming processing on the data lake. So Flink community incubated Flink Table Store. So Flink Table Store is a streaming lake format. And then Apache Paimon born. Apache Paimon is a real-time lake format because we know, actually in that time, we know the lake format is not just one engine for Flink. The lake format Apache Paimon also lead to have a very good integration with Hive, with Spark, with other engines, with Trello, with Starox, with Doris. And then now Apache Paimon released 1.0 and 1.2. So this is a very, very stable version. You can use it in a very large scale. So you can see the timeline of industry development from data lake and file formats evolution and lake format evolution and real-time lake format evolution. So the payment, actually the biggest scenario of payment is using Flink Paimon and actually Spark to build a streaming lake house. So what is streaming lake house? Imagine you have actually every company has a batch lake house. So a streaming lake house is on top of the batch. You can convert some pipeline into streaming. For example, for real-time ingestion. Actually, now many companies also already converted their or ingesting into real-time ingestion. Use Apache Flink to do streaming ingesting, to do streaming update to the payment tables. And the second is full pipeline streaming. So most of the scenarios are batch processing, we know. But some scenarios can be converted, can be accelerated to streaming pipeline. So using Paimon and Flink, you can do the streaming pipeline in a data lake. So for the Paimon, for the streaming data lake, so what is the key designs for streaming updates? Actually, so what is Paimon and why is Paimon? So the Paimon ability to build a streaming data lake, the core design is LSM. So it is a log structure merge tree. So log structure merge tree is a standard of real-time system, just like RocksDB, just like a ClickHouse. So LSM has amazing update performance. So the Paimon is the only lake format combined with lake and LSM technology. So based on LSM, Paimon can support just like real-time update and real-time changelog generation, and based on the LSM, can combine Flink to do CDC ingestion and with schema evolution in streaming ingestion. So the technology, the architecture is the LSM in Paimon. In LSM is using LSM, and the SSD file in LSM is a packet file. So combine the column storage, column file format with LSM structure. And with LSM structure, Paimon can do async minor compaction, balance the write and read. So not just like Iceberg, like Delta, if they want to do some batch processing, batch update, batch merging, the table will merge all data. So, but for Paimon, for LSM, we can do some minor compaction, just balance the write performance and read performance. So we have done a real-time update benchmark for Paimon, Houdin, and Iceberg using serverless Flink in Alibaba Cloud. So the result is lower is better. So we can say Paimon have very good update performance. So not just performance, there is a very good future to let you have schema evolution in your streaming job to do streaming ingestion. So we have, in community, we have two ways to have schema evolution. The first is Flink CDC YAM, which supports CDC directly from database. You can use Flink YAM to write a CDC ingestion pipeline. And the second is Paimon CDC. So which supports CDC from Kafka. Actually, some pipeline, you don't need to just ingest data directly from database. There is a Kafka. So you can do something like pipeline, like the write graph. You can do a snapshot to sync database into the snapshot files and do an issue to Paimon table. And then start a Paimon CDC Flink job to read the changelog, read incremental data from Kafka to Paimon, and then the streaming pipeline can have schema evolution, even nested schema evolution. And then you can use Spark or Starrocks to do near real-time query on the data lake. So with this future, with these basic abilities, Paimon is widely used in the industry. For example, Taobao, Tianmao in Alibaba Group, handles hundreds of PB of data. And the largest table for one single table up to 40 million rows per second, not per day, not per month, per second. So this PB level table is very large. It proved that payment has the ability to store very large scale table data. And in Alibaba Group, many businesses use payment to achieve unified streaming and batch and improve the date refreshes by 1 hour. And in Vivo, they migrated the Hive tables to payment, enable data sorting, and use the data skipping to boost query performance, also using CDC ingestion for CDC time updates. And in Xiaomi, they built a streaming lakehouse with payment, reduced the streaming pipeline cost, and unified streaming and batch, and ensure a more stable streaming system. And in ByteDance TikTok, they built a real-time streaming pipeline with payment and use Flink to unify streaming and batch. And in Shopee, also they improve data freshness and reduce storage cost, and also use payment upon table to perform better than Hive tables, work very well with offline table use cases. So all the companies or the use case, the keywords of payment is streaming updates, streaming changelog, streaming partial update, and data skipping, and unified streaming and batch. Actually, all these things are about the core things is that payment has amazing integration with Apache Flink. So not just Flink. Just Flink is not enough. So payment itself also has very rich ecosystem. You can see CDC ingestion, Python API, SQL, Flink, Spark, Hive, Starlog, Stories, Trello. But if your company has low lake format, you can just build a complete ecosystem based on payment. But if your company already has an iceberg ecosystem, payment can be considered as a part of iceberg ecosystem because payment has a feature about iceberg snapshot. So payment can produce iceberg snapshot automatically. Payment has iceberg compatibility for a long time, but it has not been able to sync real-time files to iceberg before. Because actually, payment using LSM and payment know how to merge data files. But iceberg is not familiar with the structure of LSM. Iceberg does not merge the data files. So we cannot sync the real-time files into iceberg. But thanks to iceberg v3, deletion vector files has been introduced. So you can say with this cycle, you can declare iceberg storage and deletion vector enabled. So for this table, if you do some CDC ingesting streaming updates into payment tables, payment will produce the files and with the deletion vectors using the LSM query lookup to produce deletion vectors in real time and the iceberg snapshots. So in this way, the iceberg snapshots can be produced in real time with real-time data files with deletion vectors. So you can just query an iceberg snapshot. You can see the minutes level latency files. And your title, today the title of my talk has multimodal AI storage. So at present, the processing of AI data is relatively rough, unstructured, and memory copy resulting in a lot of waste. And now the AI, the model is about the text, is about words, is about sentence. But in future, there is a very, very big chance about multimodal data. So the multimodal storage will be very, very large. So I think it's a very chance of us to data infrastructure to store all multimodal data into our data infrastructure. So the emergence of the nice file format has brought us the possibility of bringing AI data, bring multimodal data into our structured system, even unstructured multimodal files. So you can see the graph. So actually for data, most of the cases are about fast scans. And for our RDBMS, just like a database, have very good performance about random access. And for multimodal storages, is about large blobs. You can, if you use Packet file to store large blob files, you will find that there are very many out of memory because Packet file is not for this large blob storage. So the length file format is for all cases, but is very, very good for large blob storage. So Paimon table format integrated length file format to serve AI and data engines, just like PyArrow, just like Ray, just like Flink and Spark. And with this integration, the Paimon can store multimodal large blobs and have very good performance about random access in column files, and have very good performance to add column data. And also Paimon itself has already introduced the variant type and shared invariant. So with this Paimon ecosystem in open source, our Alibaba combining these capabilities, we have built a complete set of fully managed development platform on Alibaba Cloud, and make it very easy for business to build on Alibaba Cloud. So this platform is Data Lake Formation, is DOF. Our Alibaba global business have, for example, Taobao, Tianmao, Lazada, Feizhu, and Cailiao, Ele.me. These businesses has been built the data lake platform on the DOF. So the DOF itself has lake format about the Paimon and Iceberg, also has its data management about metadata, about catalog, about bucket compaction, and provides open source REST API about the Paimon and Iceberg, and has integrated in Alibaba itself serverless engines just like Flink, Spark, and Storix. So the core benefits of this platform is open source file, open source API, and have full managed service, and has intelligent management, and has deep optimized computation. Now DOF catalog in Alibaba Cloud is in public beta and will GA in August. Now DOF Paimon catalog is now available in Singapore and Jakarta. So welcome to use, welcome to provide suggestions, welcome to provide requirements. Thank you.
Thank you, Jing Song, for that incredible look into lake storage solutions. Last but certainly not least this morning, we have Jark Wu, head of Fruce and Flink SQL at Alibaba Cloud, who will introduce us to Fruce, the next-generation streaming storage optimized for modern analytical and AI use cases. Discover how Fruce bridges the gap between streaming systems and lakehouse architectures, optimizing storage for ML feature engineering and multimodal AI data ingestion. Let's welcome Jark on stage.
Good afternoon. Good morning. My name is Jack, and sorry. It's a great honor to be here speaking as a closing keynote, and I'm currently leading Fruce team and Flink team at Alibaba Cloud. And today I'm going to share about the Fruce. Fruce is a project we started since 2 years ago, and I'm going to walk through about the motivation and the key advantages and some use cases. So let's take a look at typical data infrastructure in a company. So Kafka has been a backbone of nearly every streaming data infra out there. And then if you want to deliver some real-time insights, you need to process the streaming data and transform it with Apache Flink. And the transformed data, you may need to write it back to Kafka topics across multiple layers, like the bronze layer, silver layer, and the gold layer, which is also known as the medallion architecture. But if you want to also perform a key lookup for enrichment, like join a dimension table using Flink. But Kafka doesn't support the KV lookups. So you can't use Kafka as a dimension table. So you end up to copy the Kafka data into a KV store, like Redis, just for that use case. And then, if you want to query the Kafka topic, like to do some data exploration or data debug or for a real-time dashboard, Kafka is not queryable, so you have to copy the data again into an OLAP system, like CleanHouse. And if you want to build a data lake house for batch processing, okay, you have to copy the data again into an iceberg. So in the end, you are maintaining multiple data copies across many different systems. The Kafka, Redis, CleanHouse, Iceberg, it introduced a lot of costs and complexity, and creating data silos and hard to guarantee the data consistency. So I'm thinking that the Kafka topics at the end here actually provide zero business value because you can't query it, you can't look up, you can't even store long-term data in it. It's just used as an intermediate storage here, just like a black box. But is it a fault of Kafka? I don't think so. I think we are using Kafka in a wrong place. Kafka is very great for event-driven communication between microservices. It is also very great for high throughput log collection. But it is not good for analytics, like using with Flink, use as a dimension table, or integrate with Lakehouse. Because Kafka has no built-in schema, and the schema is the foundation for analytical optimizations. And Kafka doesn't support updates and is not queryable, which is very common in data warehouse. And Kafka is not optimized for long-term data, and it can only store very short-term data, which limits many analytical use cases like logistics. So we can see that Kafka is good for operational workloads, but it's bad for analytical workloads because Kafka is designed for events, not for analytics and AI. So it's not a fault of Kafka. It's ours that using Kafka in a wrong place. That's why we started the Fruce project since 2 years ago from scratch. Streaming storage for analytics and AI. So Fruce, in a short, this is an overview architecture of Fruce. So in a nutshell, Fruce is a streaming storage that supports sub-second streaming read and write. It is built as a columnar log streaming storage that's built on top of Apache Arrow, So with Apache Arrow, which is a column format, we enable Fruce with a strong analytical capability. We support streaming, column pruning, and streaming partition pruning during a streaming read. So it can reduce a lot of network cost if you are performing a streaming read. And also, it supports us very high performance real-time updates and lookups. So you can use Fruce as a dimension table with Flink to perform lookup join. And the most important here is that Fruce supports lakehouse as its tiered storage. That means you can use Fruce as a hot data, maintain hot data in Fruce local storage for fast access, and maintains cold data in lakehouse for a low cost. And we use lakehouse native format like Paimon, Iceberg, so you can use all the query engines to access the lakehouse, access the code data directly, like using Spark, Trino, Starrocks. And the key feature here is called union read. A union read truly unifies the data streams and data lakehouse. Union read can read the combined data set of the hot data in Fruce and the cold data in lakehouse. It first reads from the batch data and switch to the streaming data without any duplicates or missing records. And now, Flink is already supported the union read, and Starrocks is working in progress. And there is also a Starrocks session in this afternoon in Lakehouse track to share more details about the integration. So if you are interested, you can go and have a listen. So with Fruce, you can now get a real-time streaming lakehouse for your unified data infra. So there is only one single data copy of your data, and your query engines can directly to query the single copy of data. So it provides the streaming read and write for Flink stream analytics. It provides the KV lookups for your dimension join. It provides the union read for OLAP queries. It provides the open lake format for batch processing. So compared to the previous beginning architecture, so you don't need to maintain multiple data copies across different systems. So it can reduce a lot of cost for you and simplify the data infra a lot. So real-time streaming lakehouse is not a new lakehouse. It is about to enhancing your existing lakehouse with the streaming ability to enable the data sharing between data streams and data lakehouse. So in order to achieve this data sharing, Fruce maintains a tiering service that continuously converts Fruce data into the lakehouse format like Iceberg and Paimon. This is very similar to some database systems that have multiple data layers in the system. The hot data layer, warm layer, cold layer, and so different layer is in different storage media and in different formats. The system will decide the data into which layer and guarantees the data consistency between the layers. And Fruce does this in a similar way, but just use the open lake format as the code layer. So the code data can be open and accessible by the lakehouse ecosystem. For example, you can use your Spark, Trino to access the lakehouse data directly. So this is a unified system that you can see the Fruce. It serves as the real-time data layer for lakehouse to storing short-term and second-level latency data. And on the other hand, lakehouse acts as a historical data for the streams to storing long-term and minute-level data. And when you want to read a stream, the Lakehouse provides the historical data for a fast catch-up. And when you are running batch analytics, the streams, the Fruce provides the fresh, latest fresh data from the past few minutes for the Lakehouse to make the Lakehouse analytics to be a truly real-time data analytics. Okay, so you may be wondering what if Fruce is so great, what is the production schedules and use cases? And I want to share that Fruce is already in production at Alibaba at a large scale. We are migrating our internal Kafka system to Fruce, especially for the real-time analytics use cases. And the adoption is growing as we expand the usage. Currently, Fruce is managing over 3 petabyte data size in total with clusters that handle an ingest throughput of 40 GB per second. And it also supports very high performance KV lookups up to 500,000 QPS on a single table. And the largest table contains over than 500 billion rows. Beyond the numbers, I want to share some use cases in Alibaba production. And the first use case is log collection and real-time analytics. At Taobao, which is the largest online shopping platform in China, we collect many different logs from apps and websites, including the click string, user behavior, order string, and so on. Well, the log is very foundation for the downstream analytics and AI machine learning. But the team is facing large challenges when using Kafka because the data volume keep growing every year. And it is expensive to retain the data for 3 days. But the users want to retain more days than the 3 days. So it increases a lot of storage cost here. And meanwhile, the log is a foundation for many downstream jobs. It is very often that one write, 10 read for a single topic. And the cross-AZ traffic is also very expensive. So they are also facing a very high network cost. So after switching to Fruce, they leveraged the shared data of the streaming lakehouse to keep the long-term data in lakehouse so that they can reduce the data in Fruce by 30%. And Fruce is a columnar streaming format, streaming storage. So with the column pruning and the partition pruning, they can reduce a lot of network cost by avoid transferring the unnecessary columns or the unnecessary partitions. So in total, compared to the previous solution, the team reduced the total cost by 30% and reduced the read traffic by 70%. The second use case is delta join for large-scale streaming join. Streaming join is a very basic operation in Flink to join 2 streams for enrichment. It requires to store all the upstream data in Flink state. And it makes the Flink state very large, which introduces a lot of issues. But the Flink state is just, the join state is just a duplicate of the upstream data. And in our search and recommendation team, they need to join the page click string and the order string for the attribution analysis to know what did the user see that lead to a purchase. But the click string and the order string is super large, which lead to a 100 TB state size. And this makes the job very unstable and frequent checkpoint timeout. So we introduced the delta join in Flink, which leverages the Fruce key functionality like the streaming read, the changelog feed, and the key lookups. So delta join is, you can think delta join of a bidirectional lookup join, that when the data arrive from left string, it performs the key lookup on the right table on the join key. And when the data arrive from right string, it does the same thing on the left table. So it is stateless like a lookup join, but it guarantees the same semantic like the stream join without to maintain the large state in Flink job. So after this, switching to the delta join with Fruce, they completely eliminate the 100 TB state size. And this makes the job very stable. The checkpoint time reduced from 90 seconds to 1 second. And also it cuts the Flink resource usage by 85%. And beyond that, I think the major benefit is that the decoupling of the state and the job logic. So the changes to the Flink job is no longer to require a reprocess of the entire state. So it makes the Flink job updates more faster. And also users can inspect the join data directly in the Fruce. And the good news here is that we have already donated this delta join into Apache Flink, and it will be included in the upcoming 2.1 release. And if you are interested in this, there is a Flink 2.1 session in analytical track in this afternoon, where Lincoln will share more details about the design and the implementation of delta join. I'm also very excited about the future roadmap of Fruce. First, we will continue to enhance our streaming lakehouse solution to support more open lake format like Iceberg and Data Lake. And we will support more query engines like Spark, Trino, Starworks. Meanwhile, we will support the multimodal AI, including support to real-time ingestion of the multimodal data, and also integrate with lines into our streaming lakehouse. We will also plan to release a Python client with a deep integration with PyArrow, because we are using Arrow as our underlying log format. So it is very easy to integrate with PyArrow. Based on PyArrow, we will connect to the Python ecosystem like Pandas, Polars, DuckDB, and so on. So I want to share more thoughts behind the roadmap. In the AI era, I think we need to rethink what new demands and new challenges will the data infra face. I think there are around 3 key points here: the multimodal data, the streaming data, and the open data. The biggest difference between analytics and AI is that analytics works on structured data, but the AI works on the unstructured multimodal data, like text, images, audio, video. So the multimodal data will become more and more important in the data and the AI infra. And secondly, the AI and agents will no longer rely on the yesterday's data. It requires the real-time streaming data to perform accurate and instant decisions. And lastly, the interoperability matters more than ever. Just like analytics, AI also needs its open data format. So we believe that Lens has a big potential to become the open format for AI. So we will have a deep integration with Lens. So here comes the full picture of the upcoming release of the Fruce to involving Fruce beyond the analytics into a real-time pipeline for multimodal AI. So it will support to ingest multimodal data in real time and storing multimodal data in streaming format, and streaming converts them into Lens format. And from there, you can connect to the Lens ecosystem, including tools like Ray and PyTorch. And with the upcoming Fruce Python current, you can connect to the Python ecosystem like Pandas, Polars. And I think it will unlock a lot of use cases like real-time multimodal agent, real-time AI data lake, real-time feature engineering, and more. Okay, let's take a look back at the open source journey of Fruce. We first open sourced Live on Stage at Flink Forward Asia 2024 in Shanghai. And after that, we continually growing the community. And currently, we have 1,200 GitHub stars and more than 50 contributors across the world from companies like Alibaba, ByteDance, eBay, Ant Group, Xiaomi, and Tencent, and so on. The community also have a fast development pace with three releases in 6 months. And half a year ago, we open sourced Fruce at Flink Forward Asia and committed to donate the Fruce to Apache Software Foundation in this year. So today at Flink Forward Asia 2025, we are very proud to announce that Alibaba has completed the donation of Fruce to Apache Software Foundation. And it is now an incubating project under ASF as Apache Fruce. And you can visit the new repository by simply replace the Alibaba with the Apache in the previous GitHub URL. Joining into Apache Software Foundation, I think it is a big milestone for Fruce community, and I think it is also a new beginning for Fruce open source journey to make Fruce more open, more community-driven, and vendor-neutral. And yeah, it is very welcome to join Fruce community for any contributions. Last but most importantly, we have launched the private preview of managed service for Apache Fruce incubating on Alibaba Cloud, and also now available in Singapore region. So feel free to scan the QR code to join the private preview program to explore the next generation streaming storage. Okay, that's all of my presentation. Thank you.
Thank you to all our keynote speakers for their incredible insights this morning. From real-time AI strategies to streaming storage innovations, we've explored how the Apache Flink ecosystem is driving the next generation of real-time computing and AI transformation. Before we break for lunch, I'd like to once again remind you, continue sharing your experience on social media with hashtag FlinkForward and claim your gifts at the Share Your Experience desk on the 3rd floor. Please enjoy your buffet lunch at the location indicated on your lunch voucher. Breakout session speakers are requested to arrive at their designated session rooms by 1:30 p.m. to meet with the track chair and review their slides on site. Afternoon breakout sessions will begin promptly at 2 p.m. on the 4th floor. Don't miss it. Thank you, and enjoy the rest of your Flink Forward experience.